Before the first bite, before the sizzle, before the smell hits the back of your brain and flips the nostalgia switch, there's a journey that begins far from the drive-through window or the neon glow of a sign. Because a burger, despite how fast it's served, isn't fast food at all. It's a long, intricate dance of machinery, meat, and memory. It begins with the patty. The meat that becomes a burger doesn't come from a single cut of beef. It's built from the trimmings, chunks left over from carving steaks and roasts. These trimmings are cold, solid, and rough, but inside them is the raw potential for flavor. They arrive frozen in huge blocks, packed tight into crates. In the receiving room of a factory, forklifts hum and pallets stack high. Temperature matters here. The meat must stay cold, but not too cold to grind. This is the balance. Safety without sacrificing texture. The trimmings are first separated by fat content. Some are lean, others are marbled with white ribbons of fat. Technicians in protective gear run tests to calculate the exact ratio needed for each batch. A standard burger patty aims for about 80% lean meat, 20% fat. That mix gives you juiciness, structure, and that signature sizzle. Massive grinders take over. The meat is fed in through chutes, where rotating blades slice it into fine strands. Conveyor belts move the ground beef into large stainless steel vats. Then it's mixed, sometimes with seasoning, sometimes plain, until the texture is uniform. Blades slowly churn the blend, ensuring every handful tastes exactly the same. This is where the smell begins to change. What was once raw and cold starts to smell rich, savory, almost ready. Next comes the forming machine. This machine doesn't cut or slice, it molds. A hydraulic press pushes the beef into molds, stamping out perfect, uniform patties. One by one, they're laid onto conveyor belts. Not by human hands, but by robotic arms that work faster than the eye can follow. Some machines press more than 1,200 patties per minute. Each patty is the exact same weight, the same diameter, the same thickness. That's no accident. Consistency is the key to mass production. Whether you eat this burger in Los Angeles or Singapore, the goal is for it to look and taste exactly the same. Depending on where the patties are going, the next step varies. Some will be flash frozen. These travel to grocery stores, food service distributors, or fast food chains that cook them on site. They enter a freezing tunnel where blasts of air at minus 40 degrees Celsius solidify their shape and lock in freshness. In just a few minutes, the patties are rock solid. Other patties take a different path. They go straight to the broiler. Inside a tunnel of fire, conveyor belts carry raw patties through gas flames or electric heat. This is where the browning happens. The Maillard reaction begins, the same chemical process that gives seared meat its flavor. Grill marks are added, often by branding rollers or direct flame jets. In just under a minute, the patty is fully cooked. Sensors check the internal temperature of random samples. Probes ensure that every patty reaches food-safe levels. Nothing is left to chance. Out of the tunnel, the cooked patties move on to the cooling line. Air circulates around them, dropping their temperature quickly and safely. From here, they are stacked, flash frozen, and sealed in plastic packaging. Machines vacuum seal the packets, label them, and group them into boxes. Pallets are wrapped, coated, and loaded into freezers, ready for shipment. But a burger is not just a patty. It needs a stage. That stage is the bun. Buns are made in massive commercial bakeries that run around the clock. Each begins with a mixture of flour, water, sugar, salt, yeast, and fat, usually vegetable oil. These ingredients are poured into enormous spiral mixers. Each batch can produce enough dough for thousands of buns. The dough is kneaded mechanically until smooth and elastic. Then it rests, letting the yeast do its work. This fermentation process allows the dough to rise, creating bubbles of carbon dioxide that make the bread light and fluffy. After rising, the dough is divided into equal portions and shaped into balls. These travel down long conveyor belts and into proofing chambers, warm, humid rooms that simulate the conditions of a small bakery, but scaled up by a factor of 1,000. As the dough balls proof, they double in size. Steam is sprayed over the tops, and sesame seeds are sprinkled in a perfectly even layer. Then they head into the oven, a tunnel nearly 100 feet long, kept at 200 degrees Celsius or higher. The smell is incredible. Yeast, sugar, and browning crust all combine into something unmistakable, something comforting. After baking, the buns enter a spiral cooling tower. It looks like a parking garage for bread, looping upward in a slow descending spiral. Fans circulate cool air. If they're packed too soon, the residual heat creates condensation, which ruins the texture. So they wait, spinning slowly, cooling gently. When cool, the buns are sliced horizontally with high-speed rotary blades. They're then inspected by cameras and sensors. Misshaped buns are rejected automatically. The rest are bagged, sealed, and packed into trays. Alongside the buns and patties are the fixings: cheese, pickles, onions, lettuce, tomatoes, sauces, each prepared in separate, highly specialized facilities. Cheese slices are cut from massive 40-pound blocks. They're sliced, interleaved with wax paper, and packed cold. Pickles are sliced en masse in giant brine tanks, then drained and sealed. Lettuce is shredded with air blade choppers. Tomatoes are washed, cored, and sliced in synchronized slicing machines that produce thousands of perfect circles per minute. Every single item is labeled with origin, date, temperature range, and destination. Traceability is law in food manufacturing. If something goes wrong, you need to know exactly where, when, and how it happened. All these ingredients arrive at assembly centers or restaurants. And in some factories, burgers are assembled entirely on site, then flash frozen for shipping. On those lines, buns are toasted by conveyor toasters. Patties are reheated or grilled fresh. Cheese is laid down by robotic arms. Sauces are pumped through measured nozzles. Lettuce and pickles are portioned, and the top bun is lowered by machine. The final burger is wrapped, sealed, labeled, and packed. Every step is timed to the second. Every movement is monitored by a central computer system that ensures output matches demand. Elsewhere, the pieces are simply shipped individually to fast food restaurants, cafeterias, or commissaries. There, a different kind of assembly line takes over. Restaurant workers unwrap buns, drop patties onto flat tops, flip with muscle memory, stack, wrap, slide into bags. It's fast, but it's still part of the same machine. Step back, zoom out. What looks like fast food is actually the result of a global system of agriculture, engineering, logistics, chemistry, and culinary science. It's not just lunch, it's a miracle of planning. Every burger you hold in your hands is the result of hundreds of people, dozens of machines, and an invisible chain that connects farmers, scientists, bakers, engineers, and truck drivers. And yet somehow it all fits into one hand. Warm, software familiar, delicious. That's the real power of a burger, not just its flavor, but its story. The way it compresses complexity into comfort. The way it makes something so industrial feel so human. From pasture to patty, flour to fluff, conveyor belt to cardboard sleeve, this is how a burger is made. And tomorrow, the whole cycle begins again.